Hi guys, today we're going to be working on transforming sine and cosine graphs. So the last two sections, 8.4 and 8.3, we worked on the sine and the cosine graph. So what we know about the sine graph is it starts at the midline, goes up, back to the midline, down, and back to the midline. Now, something to remember, these little dots don't really mean anything if we don't know what the scale is. So this is 1 and -1. This is, I'm going to make that a little smaller, pi over 2. That is pi, 3 pi over 2, and 2 pi. This would be negative pi over 2 back here. So that's our sine graph. Goes up, back to the middle, down, then back to the middle. One piece of information I want to add in here, I think I mentioned it before, but this place that is partway, exactly halfway between the highest and the lowest, that is called the midline. In this particular graph, because of this distance, sorry, just one second, this distance right here, that has an amplitude, and this is the parent graph, so that amplitude is 1. All right, that's it for that graph. So let's take a look at the cosine graph. Same scale with the cosine graph, 1, -1. This is negative pi over 2. This would be 0, pi over 2, pi, 3 pi over 2, and 2 pi. Difference with the cosine graph, it starts up at 0, 1, goes to the midline, goes down, back to the midline, and it goes back up. Now what I've drawn, ooh, that was crooked, on both of these is just one period. For both of them, it would also continue to go back. I probably had that go down a little bit lower there. But that's just one period in the solid lines. Okay, so now we want to talk about what we remember from transforming parent graphs. Those two that we just looked at were the parent graphs for sine and cosine. So we're going to kind of remind you of a couple things we know. Y equals x squared is the parent graph for a parabola, so it has a locator point at 0, 0, goes out 1 and up 1, out 1 and up 3, keeps going from there. That's the parent graph. And when we make these movements, this a value stretches or compresses it. This h value moves it left and right, and this k value moves it up and down. H, always the opposite of what we think it's going to be. So first of all, our hk is going to be the point 3, 5. So I'm going to go over 3 and up 5 and make my first point. Now normally with a parabola, from our locator point we'd go out 1 and up 1, out 1 and up 3, but we have an a value of -2. So the negative tells us we're going to go down instead, and we're going to go down, out 1 and down 2 because it's -2. Parabolas are symmetric, so we're going down in both directions. And that 1, 3, 5 pattern, each of those is getting multiplied by 2, so out 1 and down 2, out 1 and down 6. So that's our transformed parabola. So with the sine and cosine graph, we're going to deal with them in very similar ways. A change in k has to do with the midline that I talked about before. So the midline is halfway between the lowest and highest point. So this midline is at y equals 1/2. And since my amplitude remains 1, we're going to do one change at a time here. We're going up 1 from the midline and down 1 from the midline. This equation is just going to be 1/2. Whoops. Nope, just kidding. It's just going to be sine x, that would be our parent graph, and then a change in k, which moved it up 1/2, so plus 1/2. On the cosine graph, our midline, going straight through the middle there, is at -2. That one's going to be cosine x minus 2. So our midline is at y equals -2. So if we're graphing these, figuring out what our scale is going to be is important. So we have pi over 2, pi, 3 pi over 2, and 2 pi. We know that this has to be moved down, -2, so we need to go a fair amount in our scale. So -1, -2, -3, because we have to be able to go up 1 and down 1. So we're going to change the midline. We're going to make that midline at -2. And then we follow our typical sine pattern. We're going to start on the midline. Oops, too far. Go up 1, back to the midline, down 1, back to the midline. I almost always draw that midline. I find it easier to draw the thing. All right, let's take a look at that cosine graph. Same scale over here, pi over 2, pi, 3 pi over 2, and 2 pi. We're going to +1. Actually, I'm going to spread that out a little because I only have to go one above it and one below it. So +1, +2, over here to be at -1. And then I'm going to draw my midline at 1, since that is my k value. Cosine graph starts up 1, or whatever the amplitude is, from the midline, goes back to the midline, down 1, back to the midline, back up. So there's my cosine graph with a change in k. Next up, we're going to do a change in h, which changes the the horizontal starting point. So instead of starting at 0, we're just looking at the solid one, because in reality there are infinite numbers of equations for these things. We're just going with the one that's in solid lines. That makes it a little bit easier, at least for teachers to grade. I'll say that. So this sine graph has moved from 0 right pi. So that's going to be sine, and then in parentheses, x minus pi. Remember, if we move it right, then it's minus. If we move it left, it's plus. On the cosine graph, we've been moved from, we would normally be here to start, and we moved it left, negative pi over 2. So that's going to be cosine x plus pi over 2. And we're just making the changes in h right now. So what I tend to do when I do this, let's get all of the scales in there real quick. Okay, now that my scales are in there, I want to look over here at this sine graph over here. So if I need to go beyond 2 pi, this is 1 pi over 2, 2 pi over 2, which is just pi, 3 pi over 2, 4 pi over 2, 5 pi over 2, 6 pi over 2, so on and so forth. So I just wanted to make that part clear. All right, so down here, cosine graph plus pi, that means we're going to move it left pi. Cosine starts not, so this would be my midline because there's no change there. And then I'm going to go ahead and make a horizontal starting place as well. So this little space right here, and these are all in dashed lines because this is not technically part of my graph, I'm going to start, that becomes my new origin basically. So I move it up, that's my first point, midline, down, midline, up. So that is one period of the cosine graph. On the sine graph, again, my midline stays at 0, but my horizontal starting place starts right pi over 2. And my sine graph starts at that intersection, goes up 1, back to the midline, down 1, back to the midline. And that's my sine graph that has been transformed or translated right and left. Okay, or right in this case. All right, changes in A are changes in amplitude. And the amplitude is the distance between the lowest and the highest point on the graph divided by 2, or the distance between your midline and your highest point, or your midline and your lowest point. So this particular graph has an amplitude of 2. This particular graph, we look at our midline. That one has an amplitude of 1.5 or 1.5. So as I write these, the first one that starts on the midline, so that's going to be sine. Whoops, I guess it would help if I actually wrote my amplitude there. So 2 for my A value, sine, and it hasn't been otherwise changed, so just 2 sine x. The cosine graph is going to be 1.5 cosine x. So if we sketch these graphs, what we need to do is, again, figure out our scale, and this is the part where we can change it. If I know this one is going up to 3, I'm just going to make that 3, and that's going to be negative 3. Pi over 2, pi, 3 pi over 2, and 2 pi. I'm going to make that 2, and that negative 2 because of those amplitudes. Pi over 2, pi, 3 pi over 2, and 2 pi. When we start mixing up and adding multiple transformations, you have to think about what k is, and you need to go 3 above that on this scale and 3 below that. So as we draw the 3 sine x, starts at the midline as it usually does. It goes up to 3 at pi over 2, back to the midline, down to negative 3, back to the midline. So it's just been stretched vertically. Cosine graph starts up at 2, back to the midline, down to negative 2, back to the midline, up to positive 2 again. And that's my cosine graph. So let's put all this together and think about what we know. So I'm going to, on each of these, I'm going to address my midline and my horizontal starting point. My horizontal starting point is going to be at pi. So first we got to get some scales in here. And rather than do every single number, which is kind of obnoxious, I'm just going to do a few. All right, so let's put on my midline. I know that K is my midline, so I'm going to do a horizontal line at 1. And I know that pi is my my horizontal starting place. So I'm going to do a vertical line at pi. So my starting place for the sine graph is going to be right here. I have no change in A, so I'm just going to go up 1, midline, down 1, and back. And that's going to be my sine graph. And note that I'm not going down to negative 1. I'm just, God, my hand is shaky today. I'm just going up and down and whatever is necessary. So next up, 3 for A, change in H of pi and change of K of 1. So I need this to go up to 4. I'm going to go ahead and leave this as 1, 2, 3, and 4, which is barely on there. Negative 1, negative 2, negative 3. Make that pi, 2 pi, 3 pi, and negative pi. So my scale there is pi over 2. I just don't want to write all of those in there. So again, I'm going to draw my midline at 1. My horizontal starting place at pi. And then this is a cosine graph, so I'm going to start it off of, it's not going to start at that corner, it's going to start 3 up, whatever my amplitude is, so it's going to start right here. So my first point, down to the midline. I'm going to go down 3 for that A value, back to the midline, and up. that's going to be my transformed cosine graph. Next thing I want you to note is this negative on both of these graphs. So what's that is going to change is that on my sine graph, where I start at the midline and go up, this time I'm going to go down. My cosine graph, instead of starting 3 above, I'm going to start below. So I'm going to have to change my scales for the other one. Sorry, I was thinking to myself. Okay, so let's get the scales on here. So 2, -2, -pi, pi, 2 pi, 3 pi. Over here, I have an a of -2 and an a of -3 and a k of -2, which means I have to go 3 below and 3 above -2, which means I need my scale to go down to -5. So what I'm going to do is make each line worth 2, so -2, -4, and -6. 2, 4, 6, and then I'm going to keep my scale at pi over 2. Okay, so let's start over back at the sine graph. I'm going to get my midline at -2 for that k value. Horizontal starting place, this is plus pi, so it's going to be at -pi. So that moved my origin, so it would have been starting here. Now we're going to start here. My sine value is, my a value is -2, so my first point is here. I'm going to go down 2, back to my midline, up 2, back to my midline. So that is my transformed sine graph. The cosine graph, let's get the midline in there at -2. Remember, this has a changed scale, so we got to be careful. And then this is x minus pi over 2, so we're going to move right pi over 2. And then we need to start 3 below, so we're going to be down here. Remember, this goes by 2, so this is 1, 2, 3. So this is going to be where I start my graph. So 3 below, back to my midline, 3 above, or 1.5 lines, back to my midline, 3 below my midline. So there I go. Now, all these dashed lines are not necessary. You don't have to put them. If you do put them, make sure they're dashed so it's clear they're not part of your graph. But I put them because I find it helpful to keep track of where everything is supposed to go. Some people will even put some other things, like they'll put a maximum dashed line and a minimum, so you know that's the lowest and highest you're supposed to go. For some people that can be helpful. For other people it can be too much. So that's it. That's our transformations for our sine and our cosine graph. And next time we're going to be doing change in the period, which will shrink and stretch our graph horizontally. Have a lovely day.